What we're dealing with here is we want to do cosine. We now want to graph cosine. That is the x-coordinates of the unit circle. And so if you notice that the sine and cosine, the reason why they call it cosine is because cosine complements sine. And so as one pushes and pulls, as one pulls towards sine, the push is towards cosine and vice versa. So they kind of react to each other as a kind of, brother and sister type thing. So they're equal at pi over 4. Okay, so pi over 4 right here at the middle is we will actually see that that is actually radical 2 comma radical 2. Like that coordinate is right there at pi over 4. Okay, that's where they're both the same. Now in your calculator, radical 2 over 2 is 0.707, I think. Something like that, maybe. So if this is 0.707, then this one is also 0.707. So there are times where they're actually equal to each other. And that's that pi over 4 family. That is 45 degrees. So when we get to cosine, though, things have changed, right? If I go to the unit circle, if it's 0 degrees, I'm not at 0, right? At 0 degrees, the x-coordinate is actually a positive 1. If I go to positive 2, that means actually cosine retreats back to the origin and becomes 0. And if I go to pi, well, then I'm at the other side of the origin. So I'm actually at negative 1. When I get to 3 pi over 2, I'm actually at 0 again. And then as I go back to 0, or 2 pi, then I'm back to 1. So the way that this looks is that if I go all the way to 2 pi here, pi over 2, 3 pi over 2, what I get then is actually my maximum value is 1, negative 1. My maximum value is positive 1, but it actually starts here at 0 degrees. So cosine is different. Cosine is the same basic sine wave. They look identical, but he's shifted. Okay, he starts at a different location and then he executes the wave. All right. So he starts at 1, okay? He actually ends at 1, right? Those are identical, okay? So I start from 1, then I actually go down to 0, and when I reach 180 degrees, I reach negative 1. Then I actually start to come back up, and then I reach 1 again. So this guy continues the pattern. So cosine is essentially the sister of sine. All right, it's complementary to sine. And that produces the same shape of a wave, but in a different location. All right. And if you remember, that's very, very important when you say, want to do like 3-phase electricity, you need to know like where your wave actually is, because if these guys intersect with each other, what happens is that they start to they become harmonic, and then therefore they actually get bigger, like not longer but taller. Okay, and so if you're dealing with electrical current, that's actually very important. Okay, so that's cosine. So sine and cosine are essentially that is the co. Okay, the co is because it is very complementary to sine. Okay, they complement each other. And so these two curves are absolutely essential to understanding advanced trigonometry. All right. And what we're going to do then is I'm going to stop this video actually very, very soon and just recognize that here we have sine and here we have cosine. Now with all functions, we have these parameters that we can kind of transform them, right? And we saw that we can have waves that squish together really close and get a real high frequency and like drive us crazy. Real low frequency is the bass, that bass sound. All right. And so we want to know which one of these changes the bass to high frequency, what changes volume. If a wave is very tall, that means that the amplitude or the volume is very high and low. So there's all kinds of things that are very, very important, especially like if you wanted to ever go into computer programming and want to create sounds, you need to know the nature of a sine wave so you can do the proper trigonometric functions to it and change those functions to do it. For example, last example, if you wanted to program a beeper, like a buzzer. Okay, let's call it a buzzer, and you wanted to just hit, on. You wanted to turn it on. It would just go. But if you want to change the wave of that sound, you want it to go high and then low, high, then low, high, and then low. And what it does is it creates a siren effect. Like that's like what we're talking about. That's what a sine and cosine wave does. It essentially will make it variable. It will change the wave so it's not just this constant kind of sound. It will actually just change. Okay, so that's the importance of a sine and cosine wave and why we actually want to graph it. All right, so I think my cat just fell down the stairs, which is very weird. So let's call it here. Still not ready for your homework yet. We're going to get to that in the next video.